Hello, everybody. It's the Deephaven community team here again, August week 4, and we're going to show you a few of the features that are coming up in our new release. Here we go. All right, first off, we got JJ. He's going to show off your new Python variable scoping fixes. So, JJ, take it away.
Thanks, Bender. Let me share my screen here. So over the course of the last few weeks, some of the devs have put together some, sorry, let me share a specific tab, have put together some stuff. So it turns out that bridging Java and Python can get a little complicated sometimes. And when that does happen, some variable scoping stuff can get mixed up. And so previously, there were some things in Deephaven that doing them didn't feel natural for Python users and what they're used to. So Python uses the LEGB rule for variable precedence or scoping precedence, which L is local, so local scope, for instance, something defined inside of a function like here, and closed is something like a function within a function, and then G and B are global and built-in, which are basically anything at the global scope. Now all of once Deephaven the release happens at the end of this month, all of the variable scoping will happen and feel very natural for Python developers. So for instance, something like this, which previously I had to do some minor workarounds to get working. Queries like this, where you want to do table operations and use locally scoped variables within a function, will work exactly as you expect them. So it'll make your development a lot easier, and it will make it feel much more natural to what you've been used to doing prior to using Deephaven. And this silly little query goes from metric system to imperial, so it actually kind of makes your table worse because I think metric system is much better.
All right. Very cool. That's going to be really handy. All right. Next up, we have Devin. He's going to demo stream tables and observability. So, Devin, take it away.
Hey, everybody. I'm going to talk about stream tables and observability a little bit here. I'm kind of motivated last week by Don's demo of the upcoming heap usage tab, which I'm pretty excited about. But I wanted to take it a step further and ask, how can Deephaven really present this data in a streaming table form to make the experience even better? So I've got a couple tables here that are defined as server-side applications, and these are stream tables. So a stream table is a table where you've got one shot to get the data, and then it's gone forever. So you'll see we've got some memory statistics coming in here. It looks like every second about 10 values are coming in. We've got one chance to grab them, and they're gone forever. We've got GC events happening here. You can see it's not as big as this table because they don't happen as often. And then we've got some more GC information down here. That's a stream table. So again, you've got one shot to get it, and then it's gone. So you might be asking, well, how the heck are stream tables useful if you've only got one shot to get the data? Like I've got 10 memory samples here. How can I do anything useful with that? So the idea is that we can have further downstream operations that actually want to retain that data. So you can either say, I want to turn a stream table into an append table and keep the full history, or I want to turn a stream table into a ring table and keep the last 10,000 or 100,000 or something like that. So server side, it's a very lightweight thing to do, to keep the last second of memory or the last GC that happens. And essentially what we can do is we can replicate what the get heap info panel is going to do with this table data. So I've got a memory plot right here. So this is kind of, it might be my own styling on it, but this is essentially what the heap plot is going to look like. It shows you the max memory and the used memory for the last, I believe it's 10 minutes right here. And so this query is keeping the last 10 minutes worth of memory to be able to show you this. But we can go further than this. We can say, what if we want more than 10 minutes? I've kind of cheated here a little bit, and I've kept some more data at the start of the program. But basically, the client will be able to, on the fly, define new functions against this data to keep it for however long it needs to keep it for. So if we go ahead and run this, so now we've got a heap plot since the program started here. Maybe it was about an hour or so, a little bit more than an hour. You can see we've got some different heap usage patterns. We've got the ramp up, we've got some pattern here. I probably started some more tables and graphs right here, and you can see the usage pattern has changed a little bit. Oh, and I've explicitly set a small heap size so we get some interesting stuff going on here. But then we can take it even further. So now that we've got this data, we can actually run operations on it. So instead of just showing the raw data to the user, maybe they want to see a smoothed out version of this. So the client, again, this is the web UI client, can define something like an EMA. Let's say we want 1 minute, 5 minute, and 15-minute EMAs. And so instead of just the raw values here, we can go ahead and mix in 1 minute EMAs or 5 minute EMAs. And maybe produce a graph that's a little bit more easy to interpret. So we can see, there's a ramp up phase, there's a plateau here, then there's a slight ramp up and a plateau here, which is kind of easier to pick out when you're using an EMA versus the original data. But we can go a step further too. Instead of just direct memory information, we can start mixing in other information into this graph that might be useful for observability metrics and stuff like that. So in addition to having just the memory stuff, like you saw, we've got some GC information here. So let's go ahead and mix in some GC information here and present this graph a different way now. So now we've mixed in how much memory does GC reclaim and what is the duration of the garbage collections. So again, this is all the information that we saw earlier. Let me simplify it here a little by unclicking it. But this is saying what is the size of memory that has been freed due to GC. And it looks like it started out every GC gave us about 35 megabytes of memory back, and later on it was giving us about 76. And this is the question, or this is the graph, how long do our garbage collections actually take? Again, superimposed on the memory view. And so this is milliseconds over here, so or 3 million nanoseconds. So looks like at the start of our program, we were hovering around 3 milliseconds. And then when the pattern of usage changed, it looks like that dropped down to about 1.5 milliseconds. So I'm really excited about potentially providing stream tables to end users for observability purposes. You can imagine mixing in CPU details on this graph and disk space and whatever else you might want to do. And the great thing is if we can present it to a user as a stream table, that core concept right there allows us to keep the memory footprint very small until somebody actually wants to do something with the information, like keep it for the whole history of the program or keep it for the last 10 minutes or whatever they might want to do.
That looks pretty awesome. All right. Next up, we have Pete. He's going to demo the baseball dashboard. So take it away, Pete. All right, Pete, I think you're muted.
Perfect. I hope you can see me now. And
yep.
Maybe you can see me as well. So I'm going to not demo a development use case, just a quick DevRel use case. We've been working as a group on something that excites us around Major League Baseball. They have a Beat the Streak fantasy game, and we've done a number of things to simulate a fantasy league and then make it available in real time. And we've tried to open up a conversation both with the people running the league as well as thereafter with media people around it to just demonstrate the power of that being able to interact with all of this data might be interesting in real time, and there's lots of cool user experiences would come of it. It happens to be, you'll see that we're running a league here where you can see that we're running with about 200,000 contestants that we're simulating having run since the beginning of the season. That's a number that's probably quite a bit lower than the number of people that are actually playing. And it just so happens, you can see the number of streaks that have run is, whatever, about a little over 4 million or something like that. They're running at least double that in any given season right now. And through this simulation, actually, we're using external models where a quarter of the people are are just making random choices. The rest of them are incrementally making more sophisticated quantitative choices. And it turns out, it is a bit of luck, but it turns out that earlier in August, one of these 200,000 contestants did hit the 57 mark. So for the first time in the 20-year history of the game, if 200,000 people were playing by our rules, somebody would have won $5.6 million. So that's kind of interesting to report, but but that's not the reason we're communicating. Really what we're trying to do is support the ideas around real-time interactions here. We have a replayer that's taking yesterday's games. We've replayed the whole season that's sitting behind this interface, but right now we're replaying. Yes, we don't have a real-time data feed available, so we're replaying yesterday's baseball games with a pitch somewhere, the next pitch in the league taking place every 3 seconds, just so it goes quickly. And you can see that we've pitch by pitch results. Hey, for each at bat that finishes, what did they get a hit or not? Did anyone care about that hit? What was the number of people that were the streakers that cared about it, and what was the longest streak? And then streak by streak in real time, we're looking at all of the different contestants. They would have names, but we gave them contestant IDs and what's happened to their streaks. And then you have the ability here to look at all of the history of streaks, from how many are there to who's picking what, to what are the favorite hitters for each streaker and stuff like this. So this can be both infrastructure that supports applications, as well as dashboard here where you're using tables. We could actually have plots, but you could also imagine these type of statistics being pushed out to mobile UIs or other interactive experiences, hopefully where you can see videos of at-bats and things like that. So if you look at all the streaks historically, and I click on that 57, and then I go to the tab, here's all the different selections that individual or that hypothetical individual made to win $5.6 million. So we think it's kind of an exciting story to tell. In the background, the DevRel team worked on very easily launching, server side resources at GCP to support these type of examples. And then Devin and Rafi made it easier and a bit more battle hardened to deliver public-facing URLs for these types of dashboards. So when I've communicated with the MLB, they're actually able to see this dashboard. They may be looking at it right now themselves. So nice work there, and we put a little bit of bow around the effort.
All right, cool. Well, that's all we got for this week. Let's go Blue Jays, and we'll see you next week. Bye.